Okay, this is going to be a video. I'm going to sort of combine some things, but basically log and exponential equations. This is going to be day one, day two combined for 2022, I guess now. What I want to do is I want to start with the concept of converting between logs and exponentials. Okay, so let's say we have log 5x equals 4. Let's say 32 equals 7 to the x. Let's say 5 equals natural log of x. And let's say 4, let's say e to the 9x equals 42. Okay, so what you have to be able to do, and this is going to be a concept as we go. I know we talked about in a previous video adding and subtracting and how that turns into multiplication division. One of the big things that you're going to want to do is going to be convert from one to the other. So you got to look at what the inverse function. So any kind of to log base, what you want to do. Okay, so here are pretty much the steps. You want to have an idea of the inverse function. Okay, so obviously anything with log base 5, the inverse is 5 to some power. You want to keep the base on one side. All right, and you want to move the location of the other stuff. We're not changing signs with this, we're just moving the location. So what I got is I got equals. All right, so this other stuff is x and 4. So this x, instead of being on the left side, is now on the right. The 4 is on the, so the right side is now on the left. Okay. The inverse function here of 7 would be log base 7. And this is the other stuff. So the x would go here. 32 would go there. Very important to keep stuff on the same side. All right, for natural log, the inverse function is e. Here's the other stuff. So the x would come over here. That would go over there. Okay, this one for e would be, this is just going to be natural log. This is the other stuff. So the 42 comes here, and then the 9x goes there. Okay, so that's the first thing. You got to know how to convert from one to the other. Okay. All right, now, from a calculation standpoint, some calculations are easy. I just want to go over in the calculator how to do some of these things. All right, so some of these calculations are pretty simple, okay? So like 2 to the 4th, 2 exponent 4. All right, that's 16. All right, natural log. There's a button right here for natural log, so natural log of 5. 1.609. Okay? E, what you do for E is you hit shift and where the natural log is and you just put that. That's 20.085. Go up to 3 decimals. Now, when you get to these logs, this is where it gets a little interesting. If you look at, there's a log button, but as if you notice, it doesn't have the base. So what you should do is you do what they call change of base. Okay, log of 15 over the log of 4. So basically what happens is this part goes up there, that part goes down there. So when you type that in, log of 15 divided by the log of 4. Okay, that's 1.953. Okay, this right here would be log of 37 over the log of 2. That's 5.209. Now you have two options with this one. You can just simply just type that in as log of 9, okay? We know that that's base 10, okay? So if you wanted to do a change of base, you could. But what you're going to see is it gives you the same answer. Log of 9 divided by the log of 10. As you see, it's the same thing, okay? So that's some brief calculations, okay? All right, let's go ahead and get into some equations, okay? All right, so solve for x, okay? All right, so let's talk about log base 2, x minus 3 equals 5, okay? And let's talk about 4 to the 2x plus 1 equals 39. Okay? All right, now, what you're going to want to do to start this out is you want to either isolate or write as a single log. Okay, we talked about those principles already. Okay, now this is already isolated. What you want to then do is convert to the inverse. Okay, so on this one, the inverse of log base 2 would be 2. Okay, all right, this other part would come over here. This part would come here. So that's the conversion we just talked about. Then you want to do a calculation. In this case, I got 2 to the 5th power. Easy stuff there, 2 to the 5th power. Gives me 32. So 32 equals x minus 3. And then very much I just want to solve for x, and that's the easy part. Just add 3, I got 35 equals x. Okay? The big thing you want to check with your logs, is that if I put this back into the original, and this is only for logs and natural logs, you want to check to see if your answer, when substituted into original, all right, it can't be 0 or negative, okay? And the reason for that is anytime you take a log of 0, okay, you get that. Anytime you take a natural log of 0, you get that. Anytime you take a log of a negative number, you get that. Or the natural log of a negative number. So you just got to check. So 35 goes in there, I'm in good shape, okay? That's only for logs and natural logs. Now this one, already isolated, that's an exponential, so that would turn into log of 4. This is going to switch, so that's 39 and 2x plus 1. All right, so what I want to do here with this is I want to use a change of base. So I'm going to go and do log of 39, log of 39 divided by the log of 4. All right, so I get 2.642 equals 2x plus 1. And so now I just got to solve. Subtract 1, that's going to be 1.642, and then divide by 2. All right, so 1.642 divided by 2 is 0.821. Okay? All right, and that's how you do those. All right, now let's do some ones that involve isolation. Okay? All right, let's do some ones that involve some isolation-based stuff. Okay? So let's go 5 to the 3x plus 1 minus 7 equals 43. And then let's talk about 5 natural log of x minus 4 plus 6 equals 16. Okay? So what you're going to want to do is you notice here, this is not by itself. So I got to get this 7 away. That's going to be by adding. So that's going to be 50 equals 5 to the 3x plus 1. Okay? Now, I'm isolated. I want to convert that to the inverse. So that inverse would be log base 5. That 3x plus 1 goes over here. That 50 goes here. Now I can do a calculation involving the change of base. Okay? Log of 50 divided by the log of 5 is 2.430 equals 3x plus 1. So I subtract 1. That's going to be 1.430 equals 3x. And then divide by 3. Just write 3 decimals. You don't have to worry about rounding. 0.476. Okay? This one, I got to get rid of this, and I got to get rid of this. So I would subtract 6 first. And then I would divide by 5. So I got natural log of x minus 4 equals 2. Okay? So now I have to convert to the inverse function. The inverse function would be e. This 2 is going to come over here. This x minus 4 is going to go over there. Okay? Do a calculation. E to the second is 7.389. And I would just add 4. All right, so that's going to give me 11.389. Okay? All right, I'd like to do one more with you. Okay? And that problem would be 2e to the 4x minus 8 minus 4 equals 26. Okay? All right, so what I would want to do here, pretty simply, is I want to add 4, which would give me 30, 2e to the 4x minus 8. Okay, all right. Then I want to get rid of this 2. Okay, I've got to really differentiate because the e is the function here, so that 2, I can't have that. So e to the 4x minus 8 equals 15. Okay, hold on, let's go back and look at something real quick. All right, yeah, just make sure, yep, that would be okay. All right, so what I want to do here, this is e, then the inverse function is natural log. The 15 comes over, 4x minus 8 comes down there. Okay, so natural log of 15 is 2.708 equals 4x minus 8, so I would add 8, 2.708 plus 8 is 10.708 equals 4x, and just divide by 4. Okay, all right, so I would divide that by 4, get 2.67. Okay, all right, now there's some you can practice. You'll see in the notes. You guys can go ahead and practice practice those questions. So when you do the practice, okay, in the notes, these will be the final answers. 11.83, 4.395, 1.538, 10.519, 27.299, and 99994. Okay, so as you go to the notes, if you want to get your answer key, that's what it is. In this video, I don't have time to go through all of those questions. Okay, all right, so let's move on to the next types of questions. All right, the next thing we want to talk about is start using our addition properties. Okay, so it's still solve. All right, natural log of 9 plus natural log of 2x plus 4 equals 3. Okay. Now we talked a little bit about this in previous video. That addition, what that does is turns this into multiplication. So I am going to distribute that. So that's going to be natural log of 9 times 2x, which would be 18x. 9 times 4, which would be 36. Okay. So write as a single log. Okay. Now this is natural log, so that's going to convert to e. That 3 is going to come over. That 18x plus 36 is over here. So I'm going to do a calculation of e to the third. That's 20.085 equals 18x plus 36. So in this case, it's very easy. Just subtract 36 from this. Okay, so 20.085 minus 36 is negative 15.915 divided by 18. Okay, negative 0.884. Once again, you need to check. All right, doesn't matter there. If I put that in there, I don't think that that's going to matter. 2 times negative 0.884 plus 4. I think I'm good. Yep, still positive, so I'm good there. Okay. All right, let's go on to the next type. Okay. All right, I got log of 2 x plus 2 plus log of 2 x minus 4 equals 4. Okay, so what I want to do here is I want to now distribute this. So I'm going to have to do the little box. You can use FOIL. You can do whatever you want. So it's going to be x squared, 2x, negative 4x, 2 times that's going to be negative 8. So what that's going to turn into is log 2, x squared, minus 2x minus 8 equals 4. Okay, so if I combine those, that's what I would get. Okay, now I want to convert to the inverse function, so that'd be the 2. That 4 is going to go over there. That x squared minus 2x minus 8 goes here. All right, 2 to the 4th would be 16. All right, now I want to sort of subtract the 16 over, so I get x squared minus 2x minus 24. This is a quadratic, okay? Now, what I want to look for in factoring, I want to factor that. The factors of negative 24 that would add up to negative 2 would be negative 6 and 4. Now, since there's no number in front of x squared, I don't need to do the box. I can just sort of write out what those are, all right? Now, the solutions out of these are x equals 6 and x equals negative 4. Now, what I have to do is check these in the original. Put 6 there, that's good. 6 there, that's good. Problem, if I put negative 4 there, would give me -2. So that's not a good answer. So that would be my answer to that question. Okay? All right? All right. Let's go ahead to the next question, number 3. Okay, I got log base 25, x plus 6 plus log base 25, x plus 2 equals 1/2. Okay, all right. And so what I'm going to have on this, I'm going to multiply these because that's addition. So that would be x plus 6, x plus 2. So that's x squared, positive 6x, positive 2x, positive 12. Okay, so I got log base 25, x squared plus 8x plus 12 equals 1/2. Okay, so at this point, what I want to do is I want to convert. Okay, so this is going to be 25. All right, this x squared plus 8x plus 12 comes over here. This 1/2 comes here. I can do this calculation. 25 exponent, make sure you put parentheses around your fractions. That's going to be 5. Okay, I want to bring back this by subtraction. So that's going to be x squared plus 8x plus 7. Okay, so I'm looking for the factors of 7 that add up to 8. Well, that's easy. That's 1 and 7. Okay, so what that means for me is I got a solution of x equals -1, solution of x equals -7. Let's check this. -1 in there, okay. -1 in there, okay. -7 over here, that would create a negative, so that's going to be bad. So that would be my only answer to that question, would be -1 on that. Okay, there's some you can practice with your notes. Okay, all right. I want to go over a subtraction one. I got log base 4 of x plus 8 minus log base 4, 2x minus 6 equals 3. Okay, so now the subtraction is a little bit different. That is going to turn into division. Okay, so that's going to be log 4 x plus 8 over 2x minus 6 equals 3. So remember, subtraction turns into division. Now, this would be the inverse function would be that, the 3 would come over. All you got to do is move this like this. Okay? And I'm going to do a calculation. My calculation here is going to be 4 to the 3rd. That's going to be 64 equals x plus 8 over 2x minus 6. Now, what I got to do to solve this problem is go ahead and cross multiply. So I'm basically going to distribute that 2x plus 8. Okay? So that's going to be 128x, okay, minus 384 equals 1x plus 8. I subtract 1x there. I get 127x minus 384 equals 8. I'm going to move that up here. 127x minus 384 equals 8. And just solving a basic equation at this time. 384, that gives me 127x equals 392, and divide by 127. Okay, 392 divided by 127 is 3.086. So I just got to check. I put that in there. That's going to be good because that's going to be more than 6. That's going to be good. So I'm going to be good there. Okay? All right? If you go ahead and look at that next problem, in the notes, all right, you get a solution of x equals -5, and that's going to end up going to be no solution because if you substitute that back in, it ends up being wrong. So if you're doing your practice on the next question, that's what you would have on that. Okay? Let's go to a couple of the E questions. Okay? 2e to the 2x minus 9e to the x equals -10. Okay? Now, what you're going to want to do with this is when you have this pattern where you have multiple e bases with that little 2x, we're going to substitute u for x. So what that's going to happen with the exponent rules is that's going to turn into 2u squared minus 9u equals -10. We're going to come back to substituting u from e to the x and what that means. So what I want to do is I want to factor this. So if I move that back over, it would be plus. So that's 2u squared minus 9u plus 10 equals 0. And I would factor this. Multiply these two. It would give me 20 I'm looking for the factors of 20 that would add up to -9, which would be -4 and -5. I do, because that 2 is there, I have to use the box. So 2u squared minus 4u minus 5u plus 10. All right, GCF out of this row would just be u. U times 2u would give me that. U times -5 would give me that. 2u times -2 would give me that. So my factors are u minus 2 and 2u minus 5, okay, equals 0. But what would the solutions out of that be? That would be u equals 2, u equals 5/2. Okay, now, the problem is I didn't start with the u, okay? I started with e to the x. So what I do is I put in e to the x back for both of those. All right? Now, same deal. What would you do? You would convert this to natural log. This would be 2, that would be x. This would be natural log of 5/2, and that would be x. And then I just type those into the calculator. Natural log of 2, 0.693. Natural log of 5/2. Yeah, put parentheses around it. Gives me 0.916. Okay? All right, moving on. Let's do another one. Okay? I got 3 e to the 2x minus 8 e to the x equals 3. Okay? I'm going to substitute u for e to the x. You'll use that in calculus a lot. It's called u substitution. So 3x squared minus 8x. I'm sorry, 8u. U minus 3 equals 0, because I would move that 3 back over by subtracting. So what I would do is I would do to multiply that, I would get -9. What are the factors of -9 that would give me -8? That's -9 and 1. So I got 3u squared minus 9u plus 1u minus 3. GCF would be 3u. This would be u. This times this would be -3. This times this would be 1. Okay, so my factors are u minus 3, 3u plus 1 equaling 0. This would be u equals 3. This would be u equals -1/3. Okay, now what I would want to do is put e to the x back in for u. All right, well now it's easy to solve. This is natural log of 3 equaling x. This is natural log of -1/3 equaling x. So if I type in natural log of 3, it's 1.096. Natural log to the -1/3 is, can't get it. It tells me not possible. So this part's no good. This part would be my only solution. Okay, there is one to practice in there. I'm sorry, I don't have the answer off the top of my head. Maybe I do. Actually, I do have that answer. Okay, so if you're practicing at home, okay, that next answer in the notes is -0.287. Let me go back real quick so I can give you some of those. I think that I didn't give you these ones. Okay, so when you go to practice those other ones, after these in the notes, it's -0.0865 for the first one. And it's x equals 6 for the second one. All right, so sorry about that. I wanted to make sure you get the practice answers at least. Okay? All right, so if you're doing that next one in there, that's what you get. Okay? All right. All right, we're moving on to the last problem here. All right, that we're going to do. Okay? This is a special one, and I left this to the end. Okay? This is for double exponential. Okay? If for some reason you have double exponentials with unlike bases, okay, that's the differentiation between that and the u substitution. You can see that's a 2 in that. What you're going to want to do is take the natural log of both sides. It's a little bit different of a process. Okay, so I want to take the natural log of both sides. I want to move the exponent down in front. Okay, so what's going to happen is that 5x, I'm going to take I'm going to take the natural log of this and the natural log of this, okay? All right? And so what happens there, that's going to be 5x plus 7, natural log of 2. This is going to be x minus 1, natural log of 10, okay? And then what I'm going to do is I'm going to figure out what the natural log of 2 is. Whoops. Natural log of 2, which is 0.693. This is going to be 5x plus 7. I'm going to take the natural log of 10 and 2.302, and I'm going to distribute that. Okay? So trust me on the calculations here. That's 3.465x plus 4.851, okay, equals 2.302x minus 2.302, okay? So what I want to do is I want to subtract this. Okay, so I'll get 1.163x plus 4.851. And then I want to subtract this, okay, which gives me negative 0.610. And then I just divide this by 1.163. This is a battle of decimals, all right? And I get negative 6.150, okay? All right, so that's a battle of decimals. There is one to practice, and I believe what you get for an answer on that is something around, it's like in the notes, it's 16.133, okay? So just practice that. I know that was a little bit of a long video. I wanted to put everything in one space, and if you practice those and do your formative, you'll be fine.